So hello guys, I'm going to make this video for the ones that didn't understand electronic configuration. Remember that electronic configuration is the way that the electrons of an atom or an element are distributed. And for this, we're going to need the Aufbau principle, which is this one. So I'm going to keep this here. And remember that you just have to follow the arrows, okay? And remember that this Aufbau principle, it comes from the level of energy and the sublevels and all that, all right? So I'm going to start with I was going to say sulfur, which has an atomic number of 16. So that means that it has 16 protons, but it has as well 16 electrons. Remember that if the element doesn't have any charge, that means that it has the same electrons than protons, all right? So in this case, we will work with 16. So the only thing that you have to do once again is to follow the arrows. Remember, for S, you have 2 electrons. For P, you have 6 electrons, D 10, and F, you have 14. So I'm going to start with this one. So for sulfur, it will be, I'm going to change the color, and for sulfur will be 1s2, 2s2, 2p6, and if I count now, I have 2 plus 2, 4 plus 6, I have 10. And after the 2p6, the next one is 3s2, so now I have 12. And the next one is 3p, and now I have to count. I have 12 and I need 16, so I will add here just 4. So this will be my electronic configuration for sulfur. And remember that you can get a lot of information with this electronic configuration. What is the highest level of energy here? Remember, the level of energy is the coefficient big, or the big number that you see here. And in this case, the highest level of energy is number 3. But number 3 appears 2 times. So how many valence electrons would you find in the sulfur? You will find 6 valence electrons. How many valence electrons does any element need to be stable? So any element needs 8 valence electrons. So that means that sulfur needs to gain 2 electrons. So that's why most of the time, the sulfur will work with an oxidation number of 2 negative. Remember that the 2 negative means that the sulfur will gain 2 electrons in order to have 8 electrons and to be stable. Okay, next one is manganese. Manganese has an atomic number of 25. That means that it has 25 protons, but because it doesn't have any charge here, it means that it has 25 electrons as well. So I'm going to go directly to the electronic configuration, and that will be 1s2, 2s2, 2p6, 3s2, 3p6, and I'm going to go down here. So far I have 18, right? So after 3p6, the next one is 4s2, and then I will go back to the third level. So that will be 3d, and then I have to count. So I have 18, 20, and I'm missing 5. So D can have 10, but I just need 5. So that will be the electronic configuration for magnesium. Now, remember that magnesium is a transitional metal. So the transitional metal behave in a very different way. It's not that easy to predict as the sulfur in the example before, but so far here, what information you can have? So you see that this electronic configuration ends in D. So that means that this element will be found in block D. Okay? So you will find it at the middle of the periodic table, once again in the transitional metals. But this doesn't mean that his highest level of energy is 3. His highest level of energy is 4. But if you remember, that's it. We're going to say that this is the highest highest level of energy. But if you remember, magnesium works with different oxidation numbers. So that is another story, but that will be it for this. So I'm going to do another example, one more example. Okay, the last example will be calcium. And if you look for the oxidation number, the atomic number for calcium will be 20. But here I'm saying that I want the electronic configuration for the cation, and the cation is 2 plus. So what does this 2 plus mean? It means that the calcium has lost 2 electrons. So now it doesn't have 20 electrons. How many electrons does it have? It has 18 electrons. So I'm going to present the electronic configuration for 18 electrons. So it goes as follows. So 1s2, 2s2, 2p6, 3s2, and 3p6. So that will be it. That is 18 electrons, okay? If you present the electronic configuration for calcium, it will be the same than this one, but you will need to add 4s2, right? So what does this mean? This means for the first case that the calcium has lost 2 electrons, and now his highest balance or level of energy is 3. But if you see how many valence electrons does it have, it has 8 electrons. So now it's completed. So this means that calcium is stable with 2 positive. But if you present the other electronic configuration, that is 1s2, 2s2, 2p6, 3s2, 3p6, and 4s2, that means that here you can say that calcium has 2 valence electrons, which are these 2 ones that he lost, right? So anyway, that's it. If you see an a charge with the element, that means that it gained or it lost electrons. And then you have to present the electronic configuration according with what you see on the element. Okay, I hope that you find this helpful.